Okay, guys, we are on the last activity sheet. This is still topic 5, moving beyond slope-intercept form. We are on student activity sheet 5, and this is called exploring the point slope form. All right, so let's look at this situation here. You guys remember Mr. Chen, the landscaping company. This was back from, I think, topic 2. Anyways, we had these koi fish ponds here. Using the 1 foot square tiles. So with this one, we want to know if we were going to use the 1 foot square tiles around this pond, how many tiles would be needed? So with this, we went, whoops, come on now. Okay, with this one here, this particular problem, if I were to put in tiles, I'd have 1, 2, 3, and 4 plus the 4 corners, which would mean I would need 8 tiles on this particular problem. Okay, but if we look at this problem here, and if you wanted, you could play with the tiles. You can get on Agile Mind to show this. I guess I'll go ahead and finish it now. Okay, but if we had a little bit bigger of a pond, how many would we need? Well, this time it looks like I'd still need my 4 corners. And this time the pond is 2 feet on each side. So I'd need 1, 2 tiles, 3, 4 tiles, 5, 6 tiles, 7, 8 tiles, plus the 4 corner would make it 12. And I'm not going to do the tiles this time. We're just going to go on to the third one. Okay. So this time we have the 3 foot on each side. So we'd say 3, 6, 9, and 12. We'd have 12 on the 4 sides, plus the 4 corners would make it 16 total tiles. And this one goes with your first question on your sheet. Okay. How many tiles would be needed for the 3 by 3? And we'll go ahead and show that. We'll say 1, 2. Well, it doesn't want to lock in today. 3, and then we'll repeat that on this side. Repeat it on this side. And then the last side. So we got 3, 6, 9, 12, 13, 14, 15, and 16. Okay, so now what they want us to do is we have this table, and they want us to put what we got for each of these. We had, so on the 1 foot, we had 8, 4 on the side, 4 in the corner. For the 2 foot by 2 foot, we had 12, 2 on each side. And then 4 in the corner. And for my 3 foot one, we had 3 on each side plus 4 in the corner. So that's exactly what I have here. If it's 1 by 1, we had 8 tiles, 2 by 2 was 12 tiles, and a 3 by 3 was 16 tiles. So now what I want to do is I want to look at our table. We want to know, is the pattern going to continue? And how can we be sure that it's going to continue? If I'm going through and looking this, what would happen if I added 4 tiles on, or 4 feet in the pool? Or what about a 5 foot pool? How would that change? It's yes, the pattern would continue, because for each increase of 1 foot, 4 tiles are added, because 1 additional tile is for each side is added on. Let's go ahead and turn our paper over. Okay. Question 3 wants to know, how do you know the pattern from your table? How do you know from the pattern in your table that this situation can be modeled by a linear function? Okay. And how is this pattern related to the graph of a linear function? Okay. Well, so with this, guys, what I did was I looked at the table that we just had. And what we did is we looked for the rate, the slope. We looked for the slope. My increase, in my length, when it went up by 1, my tiles increased by 4. When my length increased by 1, my tiles increased by 4. And what happened there is we saw the relationship. The change was constant. And what we found that for every 1 foot added, 4 tiles were added, meaning the slope was 4. So now let's use what we know about the rate of change from this particular situation to write an equation in slope-intercept form. So just as a reminder, guys, y equals mx plus b. Okay, that's our slope-intercept form. But in this particular problem here, they want our t to be tiles, and they want our s to be the x. Okay, and they tell us that here, where the side of the pond is s, and the number of tiles in the border is t. Okay, so remember, total always goes on that one equal side. Your total is always going to be your y. So with this, we're going to say, what I did was I said, okay, my y becomes my t. So we're going to say t equals. We don't have a number yet for our slope. The x, we just said that gets replaced by the length plus our y-intercept. So what is in every single one of these problems? The 4 corners. That does not change. That's how I got this 4 out here, our 4 corners. Okay, and then up here, we just said the slope is 4, so I can take that and plug it in there. We get the equation that t equals 4 times the sides plus the 4 corners. Okay, and we can go ahead and say that my tiles equals 4 times the number of sides plus 4. Hit submit. Next page. So now this time they want us to use the slope formula to find the equation for the line that contains the pond data. So what we're going to do, again, here's our data, okay, in case we were missing that. Okay, the other thing I want to take note of here, guys, our formula for slope. Okay, our formula for slope. As a reminder, that fraction bar and those minus signs are permanent in the problem. Okay, so what we did here is they give us this equation that they want us to use. And they show us on the problem here. So the first thing I'm going to do is find my slope. Okay, first thing I'm going to do is find my slope. So with this problem, I'm going to say I'm going to do my first one here. We can either plug things in or we can look at the change that we had. I had a change of 4 over a change of 1, which gave me 4 over 1, which equaled 4. Okay. They also want us to use one of the points. Where they chose the point 316, 3,16, and they got that from their table. Okay. And what we're going to do is we're going to plug this in. Let's just go ahead and watch. So they have the slope. We know that the slope equals this formula. We know the slope is 4. We know what the y and x are. Okay, so what they did was they plugged those in. Okay, so again, this is my x, this is my y. Here's our slope problem. What I did was I took the m, 4, and put it right there and placed the m. Now we also have our y and x value. The y was 16, the x was 3. Okay, so what they're saying now is they want us to solve this equation around. Okay, so in order to solve this, we need to get rid of this whole thing on the bottom to get that y by itself. So what I'm going to do is, because this is division, we multiply. We're going to multiply both sides by the x2 point minus 3. Multiply it on this side by the same thing. My denominator cancels with the numerator. All that's left now is this y2 minus 16 equals 4 times x2 minus 3. Now, to get this by itself, to get rid of this 4, it's multiplied. So all we have to do is divide. Oh, I was a little ahead of them. Actually, we're not dividing anything. This is the same exact thing. We're just rewriting it. That's all we did here, was just rewrite it, guys. Okay, so that's a whole lot of work. Let's just go through what happened here. Okay, all we did was we showed you where we're going to come up with this new equation. This new equation is called our point slope form. Okay, so like slope intercept, the two things that make up slope intercept are the slope and the y-intercept. So the two things that make up the point slope for the line is the point and a slope. That's the two things that make it up. And that formula is going to be y, which is permanent in the problem. That y is permanent, minus, again, permanent, the y point, so that would be like the 16 right here, equals my slope, that's a number that we plug in, times x minus the x point, okay? So again, guys, what's on my green in this greenish teal color, that is permanent in the problem. Anything that I have on this page in purple gets replaced by a number. The m gets replaced by the slope. The x1 and y1 are replaced by the numbers in a point. The regular x and y are permanent in the problem. Oh, jumped ahead here. So let's finish this one. So what they want us to do here, guys, is they want us to rearrange and simplify the point slope form of the equation that we made in question 5 to find the slope intercept form. So I'm going to actually do this on a separate sheet here so you can see it a little better. Instead of just seeing my work, you can actually see me do it. We have y minus 16 equals 4 times x minus 3. So the first thing that I'm telling you guys to do right here is to distribute. So distribute the 4 into your parentheses, and I get y minus 16 equals 4x minus 12. Okay? The next thing that we need to do is to get this y by itself, get rid of that minus 16. Well, you guys, you know that how do we get rid of a minus 16? We add 16. But if I add 16 on one side, I have to add 16 on the other side. That leaves me with y equals 4x. Be careful with the negative. Use the calculator if you need to. Negative 12 plus 16 is positive 4. That's exactly the equation that we came up with. Okay, so now question 8 here, guys. They want us to match each equation with the slope of the line and a point on the line, okay? So we have all of these options here. Let's just look on our screen real quick. So I'm going to go with my top 2 equations first. My slope is really easy to pick out. My slope here, we've got negative 2. So there we go. My slope in this equation, it's the number in front of this parentheses, which is 4. Okay. Now, on this next problem, All right, let's go back up to this one. They want to know whoops, I put these in the wrong spot, guys. They want to know a point on the line. Well, we can use the y-intercept. As a reminder, the y-intercept on this one, when x is 0, what is y? Well, when x is 0, that disappears. Y equals 5. So we're going to use the point 0, 5. On this one, okay, this is in point slope form. They give you guys the point. Remember, the x goes with the x value, so the x is 7, the y is 3. So 7, 3. Now, lastly here, they give you this equation. There's a couple things that we can look at here. I am going to say, let's go ahead and put this into slope-intercept form first, okay? And for those of you guys that don't know how to do this, we want to get the y by itself. So the first thing I need to do is move this 2x. I'm going to minus 2x on both sides. That leaves me with 5y equals negative 2x plus 10. And I just rewrote that in a different order. My 10 is still positive. My minus 2x, minus 2x. Lastly, get that y by itself by dividing everything by 5. And I'm left with y equals negative 2 over 5x plus 2. Okay, so here's the deal with this. I can pick out my slope. My slope is going to be negative 2 over 5. Okay, but my intercept, it would be 0, 2. They don't give us that as an option. Well, another thing we know about standard form here, guys, is that we could go the other way. We could find what the x-intercept is, meaning when y is 0, by covering up the other value. That gives me 2x equals 10. Divide both sides by 2, and we get that x equals 5. The x-intercept, so point on this line, would be 5, 0. Okay? Going on. So in an earlier problem, we had a rule that we had talked about with our gas tank in the reserve. Okay? So suppose we knew this information about a different car. Okay? We knew that when it was 1 inch of the float, there was 3 gallons in the tank. 9 inches gave me 11.4. Okay. So assuming that the rate changes with respect to the height, meaning that it is constant. So meaning that the change that's happening here stays the same. What function rule would represent the relationship? Okay. So they want to know what rule is going to represent this relationship here. So the first thing we need to do, okay, the first thing that we need to do here is find the slope. Okay, so what I did is I found my change in y's. So from 3 to 11.4, it had an increase of 8.4. From 1 to 9, it had an increase of 8. So we said 8.4 divided by 8 equals 1.05. This is my slope. The second step is to pick a point. Now, I don't know about you guys, but I wouldn't want to use 911.4. Why would you choose to use a decimal? Use the 0.13. Okay? Make it easier on yourselves, guys. And then the third thing we're going to do is plug it into the point slope form. Now, as a reminder, our point slope form is y minus the y value equals the slope times x minus the x value. So when I go to plug this in, we are going to replace this number, and this number. Okay, and that's what I get here. My y1 is replaced by the 3. My m is replaced by 1.05. That's our slope. And then the x is the x value. Okay? So that's it, guys. This is the equation right there. Now, they want to know if you had chosen to use the other point. So say you had chosen to use the point 911.4, which is fine. This is the equation you get. It's the same exact idea. We just put the 9 in the x spot and the 11.4 in the y spot. Okay, so now what they want us to do, they want us to use our equality properties to transform these equations that we just solved right here, or we just made right here, to put them into slope-intercept form. So again, guys, what we're doing is we are going from point slope. We're going to solve for y and put it into slope-intercept form, which, as a reminder, is our y equals mx plus b. Okay, so let me talk you through what I did over here, and then we'll do it together on the next one. Okay, so the first thing I did was I distributed 1.05 into the parentheses. Use a calculator, guys. So 1.05 times x is 1.05x. 1.05 times negative 1 is negative 1.05. Then I need to get the y by itself by moving that minus 3. To get rid of a minus 3, I add 3 to both sides. So with this, I get y equals 1.05x plus 1.95. Let's do this now on this one. So again, guys, this is just me using the other equation that we came up with. Same exact thing. Okay, let me get my calculator ready here. So first thing I'm going to do is, just like I did over here, we're going to distribute. Y minus 11.4 equals 1.05x minus 1.05 times 9 gives me 9.45. Now, I need to get the y by itself. Because it's a minus, I'm going to plus 11.4. Plus 11.4, and I get that y equals 1.05x plus, and you can use your calculator if you want, negative 9.45 plus 11.4, and that gives me 1.95. Notice they are the same equations because they showed us the same exact information over here. Same exact thing. It doesn't matter which points you do, as long as you do the math correctly, or you make your calculator do it correctly, you should get the correct bit of information. Okay, going on. And that's just what we did right there. So question 11 is a matching, guys. They want us to match each equation to the correct pieces of information. And just as a reminder, so review, because I'm looking at this and I see parallel, I see perpendicular. Okay, as a reminder, parallel lines have the same slope. We'll call it same slope, same m. Perpendicular have opposite and reciprocal, meaning flip it. Opposite, reciprocal. Okay. I believe I also maybe talked to you guys about when something is in standard form. Okay. Or we have point slope, y equals mx plus b. That's our slope that we're looking for. M, that's our m. If we're in point slope form, None of the equations here are like that. But if we are in standard form, ax plus by equals c, my slope equals the opposite of a divided by b. So when I look at each of these problems, guys, what I went through and I figured out what each of the slopes were. So first of all, my slope here, opposite of a would be -2 divided by b, which is -3. That simplifies down to +2/3. Same thing here. Opposite a, -3. I don't like that pen. -3 divided by b, -2. Double negative simplifies to a positive. Over here, same thing. This is like a 1. Remember Beyonce, if it's single, then you got to put a 1 with it. Okay, negative a, so -1 divided by b. -1 divided by -4 is a +1/4. This is in slope-intercept form. My slope is 3. My slope is 1. My slope is 2. My slope is -4. My slope is -1. Now that we've got all those, okay, they want a line that contains the point 1, -2, and is parallel to the line given by the equation. So again, guys, we said parallel equals the same slope. So this slope is 2. What other slope did we say had a slope of 2? 2x minus 4. Okay, this equation has a slope of -4, but they want perpendicular. So opposite would be a +4. The reciprocal would be +1/4. So our answer choice was 1x minus 4y. Oops, it looks like this one didn't. Now they want contains the points 1, 2, and 2, 5. The easiest way to go about this, guys, you can make an equation or you can sit and plug these in. I'm going to find the slope between these personally. That's going to be my first choice here. So if I'm looking for the slope, the change in my y's, 5 minus 2 over the change in my x's. 5 minus 2 is 3. 2 minus 1 is 1. 3 over 1 is 3. I only have one equation up here that looks like that, so we're going to call that our 3x minus 1. Now we've got 2, 0, and 0, -3. So I'm going to say -3 minus 0 over 0 minus 2. And that equals -3 over -2, which is +3 over 2, which we said was 3x minus 2y. And then lastly, we've got 4 minus 5 over 1 minus 0. That's -1 over 1, which equals -1. The only one up here that has a slope of -1 is this -x plus 5. And then after that, guys, it's just reinforced questions. So go ahead and work on those with your teacher.